So what I want to do is I want us to really go on a journey. And I want a journey that starts off with the very familiar and then to go further and further out to the very edge of the universe and just discuss what's out there and what we might see in the future. So starting with the familiar, I think it's quite important to start with planet Earth. I think it was Carl Sagan who described our planet as pale blue dot. And as we look more and more out in space, we find there's very few planets that have this much water. And because when you look at the Earth's surface, 4/5 of the Earth's surface is water. And if you look at us, about 4/5 of our bodies are water. So we are very much a product of our planet. And as we go further and further in space, I'll talk about that quest, the holy grail that scientists are looking for, the quest for life in the universe. We haven't found it yet, but we're still looking. And I'll talk about some of the results we're getting there as well. And I like this picture especially because I think that until we actually went out into space, we never really saw our planet as it truly is. It's an orb in space. And some people say that images like this were what triggered the environmental movement. For the first time, we saw our planet on its own, lonely and vulnerable. And suddenly we had a better understanding of it. We had a better understanding that we need to protect it. This is our home. And if we destroy it, what happens in the future? So I think I love this picture because it's incredibly iconic. We got it from space and I'm a space scientist. Okay, next stop, the moon. Very, very different from Earth. We had all that water on from Earth, and it seems we don't appreciate how much water we have here on Earth. But the moon has no atmosphere at all. And the fact that people have landed on the moon still gives me a bit of a buzz. I know it was a long time ago, but the fact people have been there. And when you look at the moon, it is quite spectacular. And I think we don't appreciate the moon. In fact, I made a documentary with the BBC called "Do We Really Need the Moon?" The answer was yes, we do. But there were various explanations for it. But one of the things we were investigating was how the moon was created. And I've got a small clip here from the film talking about how the moon was formed.
Let me take you back to the earliest days of our planet, 4.5 billion years ago. At this time, the Earth had no moon. It was orbiting the sun alone, and it was being assaulted by rocks and comets. Today, there are no scars left from this cosmic pinball. But to get a sense of the damage that was done, I've come to the Arizona desert, to a great hole in the ground.
This is a beautiful crater. A near-perfect circle, a mile in diameter. It was formed when a meteorite crashed into the Earth a mere 50,000 years ago. That's nothing on the timescale that we're talking about. But it's amazing how much damage that one passing rock can cause. The early Earth was bombarded with rocks. It must have been mayhem. And then along came something much, much bigger.
Another planet, the size of Mars, drifted into the path of Earth. It was on a collision course.
Earth with a glancing blow. Imagine the power released by such a collision.
The impact sent a mass of liquid rock into orbit. This debris coalesced into a ball. And the moon was formed. Just 14,000 miles away from the early Earth. This was the closest point it could have been. Any closer, and the debris would have come crashing back to Earth, and our moon wouldn't exist. Today, the moon is just a rock, reflecting the sun's light. But back then, it was a molten sphere, burning brightly. It must have looked amazing, an enormous orange disk in the sky. Imagine the scene, the first moonrise over the early Earth.